Okay, so we've already talked about metal identification, right, on the last workbook that we did. In that workbook, we didn't actually do the spark testing or the hardness testing because we don't have the stuff to do it. However, we did the visual, we did the hardness. Oh, sorry, not hardness. And then we did the magnetic and non-magnetic. Remember that magnetic means that it's ferrous, and non-magnetic means that it's non-ferrous, right? We talked about relative weight in the fact that aluminum's pretty light and our steel was pretty heavy. And then we didn't really talk too much about electrical conductivity. But if you take wire apart that's in the wall, you are going to find copper inside of plastic insulation because it is a really good electrical conducting metal. Perfect. So last class you saw some brass. We had some bronze. No, we didn't. We had copper, right? There was a chunk of copper. We had lots and lots of iron, and then there was that one little piece of tin that we had, right? But all of these are metals that you can find. Mercury is actually a really cool metal. It has a super low boiling point, so low that it is actually a liquid at room temperature. So, cool fact. Remember that all metals are found on the periodic table, right? So here's our iron right here, Fe. There's this is copper, this is nickel, this is zinc, aluminum, right? All of these are the base metals. And then you start getting into mixing all these kind of metals to make alloys. And alloys have different properties that make them good for us. So, but all metals come from the periodic table to start with, and then we start being chemists and we mix them together. Okay, the most common metal that we have is mild steel. This is what you are gonna deal with in the shop at all times. We might there's the possibility that you might do some aluminum welding, but very rare. Okay, so mild steel is a ferrous metal. It's magnetic. It's made of iron and carbon. It's low priced. That's why most people use it for their general engineering applications. Right, we talked about magnetic properties, okay, due to its high iron content, okay. Mild steel has a content between 0.16 and 0.29%. That makes it a relatively high boiling point, which means that this high melting can is more ductile when heated. It makes it suitable for forging, cutting, drilling, welding, and it's easy to fabricate with. That's why it's the main metal, okay. Mild steel does not have a high resistance to corrosion. That means that it rusts easily because of, where is it? You can't find it on here. The high iron content. Right there. High iron content. Okay. You can greatly improve this resistance by appropriate surface protection. So we're talking paint, powder coating, different kinds. You can get kind of not a stain for metal, but it's kind of like that where it oxidizes the metal to help protect it. All kinds of stuff. Yeah, right here. Oxide primers, metal paint, spray paint, zinc treatments, all that kind of stuff. Okay, to protect it from rust and corrosion. Moving on. Today we are talking about metal stock identification. So we talked about the fact that you can get a whole bunch of different kinds of metals. Now we're going to talk about the fact that not our whole bunch of metals can be bought in different shapes and sizes. So, right. And the different shapes and sizes, the reason we buy them is because they somehow alter the metal to make it better. I'm going to skip. Right. We're going to go back. So here, if you wanted to go buy metal, you could go to a place like Metal Supermarket. So if this opens up for me, okay. Like I said, likely you're going to buy mild steel. And then within mild steel, you can buy all kinds of different metals, right? One that we don't have in here is tread plate. So if I click on the hot rolled version of it, it doesn't even have a good picture of it. Tread plate is the stuff that would be like on the back of a combine or something in order to give grip for you while you're walking. Why don't we just Google this real quick? Tread plate. Just so we have an idea. Toolboxes. Lots of toolboxes have this, right? Oh man, it's going to be slow for us. Anyways, you can see all the pictures of what tread plate is. Okay? Perfect. So if I go back here, again, you can buy aluminum in all kinds of different shapes. You can get it in tread plate, sheet goods, angle, beam, channel, all kinds of stuff. You can buy stainless steels in all kinds of different shapes. Alloy steels. Alloy steels are much more expensive. They mix different metals together in order to get properties that make it really good for resisting rust or for ductile strength or for stuff like that. Alloy steels is stuff that like airplanes would be built out of. Okay. And then our more metals, we're talking like things like specialized metals that come right off the periodic table. So we're talking brass, bronze, copper, right? We talked about tool steel. This is what like chisels and stuff are made out of. And again, our alloy steels are the much higher, better steels. Okay, so let's go back to our slideshow here. So again, I clicked on this. There's our mild steel, and we can get it in all kinds of different stuff. Remember, we talked about hot rolled. We talked about cold rolled. We talked about adding a galvanized zinc coating to it in order to keep it from rusting. That's about it for here. Okay, so again, why do we buy a whole bunch of different shapes of metal? Because the different properties that shape gives the metal. Usually it has something to do with strength or ease of use. So something like beams or channels are used as structural applications for large steel frame buildings. If you look at a semi going down the road, the back of their trailer is likely an I-beam frame. Okay, the I shape, this is a nice I-beam. Okay, and then C-shaped is channel, and so C channel is the same one as here. Because of the way they're bent and they're made, they're not actually bent, sorry, the way that they're formed makes them much stronger. They're not able to bend as easily, right? So in this case, this building, you can see that this is an I-beam, has a nice wide flange at the bottom, nice wide flange at the top, and then the webbing through the middle. And the flat top and the flat bottom make them great for keeping things square, right? You can hang lights easily off something that's nice and flat. You can put floor across nice flat tops, right? Okay, sweet. So that's beam and channel. Tubing and pipe. While these two look very similar, they're different in application. Pipe is used for carrying liquids and gases from point A to B. This means when we're talking about dimension, we care about the inner diameter of the pipe. So this is a piece of pipe. Because water is flowing or gas or whatever is flowing inside here, when we talk about diameter, we're talking about the inside, from inside to inside. Okay? Tubing, on the other hand, is more for structural applications. We're thinking about like roll cages in side-by-sides or roll cages in NASCARs or railings, all kinds of stuff like that would be made with pipe. And tubing. And when we measure tubing, we care about the outside diameter. So again, these arrows are pointing to the outside of the tube. And the inside we don't care about when it comes to pipe. Okay, or tube, sorry. Man, I'm getting them mixed up in my own words. The other thing in tubing is that you can get tubing in different wall thicknesses. Pipe, you can get in different thicknesses, but it's much more uniform when you go to order it. Where tube, you can get quite a variation in the thickness. Okay, sweet. Sheet metal versus plate steel. Sheet metal is usually very thin. It can be bent and formed in any shape you want. This is why it's widely used for building vehicles and airplanes and HVAC ducting, like the ducting above our head that's keeping the classroom warm, right? Adding bends or ribs adds strength to the sheet and makes it harder to bend or deform. So right here we have this. This is probably galvanized. This is the kind of sheeting that you might find on a roof or on the side of a barn or something like that. So it is a piece of sheet metal that they added all these ribs to give it strength. Plate steel, on the other hand, looks similar, as in it's flat and it's a big sheet. However, they're generally much thicker. So plate steel, as you can see here, super thick, right? And these would be for applications like building dumpsters or stuff like that, where you want a lot more strength in the material without having to add all these ribs and bends and stuff. Okay. Rebar. We have chunks of rebar all over our shop. This is what our blacksmith project is going to be made out of. It's used for strengthening concrete. Rebar is usually a more ductile metal. This means that it bends kind of relatively easy as far as metal goes. It doesn't bend like that piece of tin that we had, and it doesn't bend like a piece of sheet metal, but it definitely bends easier than like a piece of flat bar or something like that. Okay. This is important because that property helps it hold concrete together. With the shifting of the earth due to things like frost, because we have the frost heaving in places like Canada, or even things like earthquakes, where we don't really feel that, but maybe somewhere down along the fault line in California would need to have strength in the concrete to resist earthquakes. Okay, flat bar has all kinds of uses. Too many to count. It's flat, which means that it's kind of flexible, right? It's not flexible if you try and bend it this way, but if you try and bend it this way, like this ring, it's easily bent, right? This means that it can be bent into circles for different applications, for rings around garbage cans, for rings around whatever you want to put a ring around, a barrel, right? So that's why flat bar is, and it's super common everywhere in being bent or staying straight. That is the end of this little